Ayan, recording na. Okay. Share. So we are now on this topic, which is the first topic for your midterms, infinite series. We're going to discuss this time your sequences, convergence of a sequence. Itong dalawa lang muna, no? These are the topics for this section. So you are aware already of your infinite series. Can you see it clearly? Ang terms na involved are tools which are powerful to solve for infinite polynomials. Okay? We can also make use of infinite series to solve differential equations that model physical behavior. So at the end of this topic, you should be able to, specifically sa section on sequences, find the formula for the general term of a sequence and then calculate the limit of a sequence if it exists. So later on, you'll be able to determine the convergence or divergence of a sequence. Were you able to take the topic, to take up the topic on sequences sa 51 or 61 class? Naka-take up mag-topic sa sequences? Hello? Are you still with me?
Yes, ma'am.
Okay. Na may sequences sa 51, 61? Wala.
Wala, ma'am.
Wala. Okay. So we have to fully discuss this topic. So we have what we call your convergent sequence and your divergent sequence. So how do we expect to learn about your convergent and divergent sequence? So we have the following terminologies. You have what you call your infinite sequence. So an infinite sequence of is actually a listing of numbers of this form, a sub 1, a sub 2, a sub 3, up to a sub n, and down the line. You have that one. And then, each of these numbers is called actually a term. So a sub 1 is one term, a sub 2 another term, up to a sub n, which is the nth term. We make use of this notation, this one, or simply this one, or sometimes simply a sub n. No? We use the set notation here, but it doesn't mean to say na set na siya lahi ang set na ano, no. Ang ibig sabihin kasi nito, it's actually a sequence of numbers. So, sequence which is actually an ordered list. Whereas for sets, ang sets kasi hindi siya ordered, no? But for a sequence, it is actually an ordered list. And then because a particular number a sub n exists for its positive integer n, then we can define a sequence to be a function whose domain is the set of positive integers. So consider, for example, this list 2, 4, 8, 16, 32. This is actually a sequence. What do you think would be the number that will come after 32?
64, ma'am.
Yes, 64. So notice that there is actually a pattern and it is ordered. No, you cannot say that after 32 you will come up with 4. Okay, so it's an ordered list. So you note that because it is actually a sequence, it's an ordered list. So you will be able to find out that the first term is 2, the second term is 4, and the third term is 16. Okay? So you call that a sub 1 equals 2, a sub 2 equals 4, a sub 3 equals 8, and you will have this a sub 1, a sub 2, a sub 3, a sub 4 is 16. Now, if I ask you what is your a sub, if this is 1, 2, 3, 4, 5, a sub 7, what will be your a sub 7? Any idea?
What's our question, ma'am? Can you
What
repeat the
is A
question?
sub 7? A sub 7. You have A sub 1 is 2. A sub 2 is 4. So what is
128, ma'am.
okay, you have 100, yes, correct, 128. Kasi dito, this is your A sub, ano yan? 3 man yung 8, 4, 5, 6, then 7 is 1. Very good. So, nakita niyo may pattern lang, no? Ang sequence. So, you have the following pattern. The pattern is A sub 1 equals 2 to the 1. Yan. What did you notice a pattern? 2 to the 1, 2 to the 2, whatever is your n here, that would be the exponent there. So a sub 3, 2 to the 3, a sub 4, 2 to the 4, a sub 5 is 2 to the 5. That's why your a sub 6 will now be what? What will be your a sub 6? Hmm? What's a sub 6? Can you hear me?
2 to the 6, ma'am.
2 to the 6, yes. And down the line, you'll be able to solve. Because of the pattern, you can write down the nth term of the sequence by this formula, which is a sub n equals 2 to the n. Is that clear?
Yes, ma'am.
Okay, good. So we now have another notation here, which is 2 to the n. This one is the other notation. You enclose it in braces. That's another notation that we have. So you can actually describe this sequence in a different way. And we call that your recursive way of expressing the nth term a sub n. So you make use of the previous term, which is a sub n minus 1. And when you do that, if we have a sub 1 equals, I think I'd rather use the laser pointer. If you have a sub 1 equals 2, for all n greater than or equal to 2, and each term is defined by the recurrence relation, a sub n equals twice of a sub n minus 1. So aside from using the explicit formula, you can also make use of the following recurrence relation. So an infinite sequence is an ordered list of numbers. So as a summary, you have that one, no? And you call this your index variable, your n here, your index variable. Each term is called yung a sub 1, a sub 2 is a term of the sequence. And sometimes sequences can be defined by explicit formulas, which is of this form. A sub n equals f of n for some function f of n defined over positive integers. Okay? Now, note that the index does not have to start at n equal to 1, but could start with other integers. So meaning to say, in the explicit formula, you can have the following. A sub 0, a sub 1, a sub 2. You can also have that one when n is equal to 0. You just consider the function a sub n equals f of n. Now, there are other, I'm sure you are familiar with arithmetic sequences and geometric sequences. So, in an arithmetic sequence, the difference, you will have arithmetic, para matandaan nyo, when it's arithmetic, you either add or subtract a certain constant to get the next number in the sequence. Okay, so the difference between every pair of consecutive terms is actually the same. We call that difference because you can actually add or subtract that b. For example, this one, 3, 7, 11, 15, 19. So what would be the next term? You already have an idea? Hello? Any idea on the next term?
23, ma'am.
4, plus 4, no?
What's your D? 3 plus
24.
plus 4, yes. So the next term would be, after 19, what's the next term?
23, ma'am.
19 plus
4, ma'am.
Oh, so what's the next term?
24, 3. 23.
Okay, 19 plus 4 will give you 23. So if I ask you what is the 100th term,
A sub
then
n is equal to a sub 1
okay.
plus n minus 1 times d.
Okay, so you actually have the following. A sub 1 is 3. A sub n is a sub n minus 1 plus 4 for n greater than or equal to 0. But you have to assume that this pattern actually continues, no? And it is an arithmetic sequence. So a sub n equals a sub n minus 1 plus 4. That is if you make use of the recursive definition, no? Recursive definition. But if we make use of the sequence, this one, so, A sub 2 is 3 plus 4. Yung kanina, may narinig ako na girl. 4 ang D. Yes, very good. You get it immediately. A sub 3 is 3 plus 2 times 4. A sub 4 is 3 plus 3 times 4. So you notice that you'll be able to create a pattern based on the uh, terms that are given. Okay? So you have this, A sub n is equal to 3 plus 4, the quantity n minus 1, or A sub n is actually 4n minus 1. So in general, the arithmetic sequence is any sequence of this form. A sub n is equal to cn plus b. Sometimes, yung ito, we make use of this, no? A sub n, as long as a sub 1 is given, and you know what is the difference, then you can compute for a sub n. This is the formula for your arithmetic sequence. A sub n equals a sub 1 plus n minus 1d, where, okay, where you actually have your nth, this is the nth term, this is the first term, this is the yung n na doon, kung ikailan yan siya, and your d is the difference. So in this case, if I ask you what is the 100th term, then you will have a sub 100 equals a sub 1 plus 99 times your d. What is your d? 4. Okay? So you'll be able to compute for your a sub 100. I guess sa MAT 071 kasi tinuturo din namin yung sum of the arithmetic progression, may mga formulas din. You can try to review that back. Huh? There are some text which talks about the summation. So here, di ba? A sub n is the nth term. A sub 1 is the first term. N is the term number. Pag A sub 100, term number yun. D is the common difference.
Ma'am, question, ma'am.
Yes, yes.
Saan
Question?
CN?
This one kasi, this is actually another general term of this form. Ito. Itong nandito. 4n minus 1. So in this case, this is ang lumabas, di ba? In this topic, you have C there is 4, and you have n, and then your B there is your minus 1. So this is another general form of this term, itong term na inaral natin earlier. Itong 7, 3, 7, this is ilan to? 3 plus 2 plus 2 times 4. Okay? So 8 plus 3, 11. Ito ang general term niya ito. Itong 4n minus 1. Ha? From here, from this sequence. Specific sequence ito. So, ang 4 dito is your C, ang N dito, yung N, minus 1, ang B ninyo is negative. Para lang sa ito na term. Okay? So, later on, you will be asked to find the explicit formula for the terms based on the given. Okay? Okay. Naintindihan na? Nakuha na yon. Pero ang formula na gamit talaga, kung i-base niyo sa ano, ito yung form na for any a sub n. This is the form. You have a sub 1 plus n minus 1d. Kanin mo na siya ang na-derive from here. Ang cn plus b. Derive from here. Then. In general, this is this form. Okay na? Okay, let's go to the next one. The other one is what you call your geometric sequence. So for example, if you consider this, okay, medyo anong geometric sequence? Tricky, na? So if you take a look at this, what is your, di ba pag geometric sequence, meron kayong ratio, that's that when you multiply to the
Common
next
ratio, ma'am.
number, yes, common ratio, you'll be able to get the next number. So in this case, if we have 2, negative 2/3, 2 over 9, tapos ang next, negative 2 over 27, sunod, positive na naman uli, di ba? Positive, negative, positive, negative, positive. Tapos ito, what will be the next number? What do you think? Based on these sequences.
Negative 2 over 243.
Okay, let's just see. Negative 2 over 2/4. Okay, you can actually compute for that, di ba? So, ang ratio is negative 1/3. So, 2 times negative 1/3. Yes, that's correct. The next term. Assuming this pattern continues, this sequence is what you call a geometric sequence, and you can define recursively as follows. Kani, you have a sub 1 equals 2, a sub n equals negative 1/3, a sub n minus 1 for n greater than or equal to 2. So what is your, because if you make use of your recursive definition in finding the formula, you need to know what is the next term prior to a sub n. This is quite difficult, diba? Especially kung very large number na itong a sub n unless given ng a sub n minus 1. So there can be some other ways of doing it. So you can see the sequence already, negative 2/3, tapos ito is positive 2 over 9. This one is negative 2 over 27, no? You have that. But, so you come up with the following. A sub n equals twice of negative 1/3 to the n minus 1. So in this case, madali lang siya kasi makita ninyo na ang a sub 2 is eto, 2 there, 2 minus 1. So that's why to the negative, to the, pag a sub 2, that is 2 minus 1. So 2 minus 1 is to the 1. So if it's 2 to the 1, negative 1/3 and so times 2. Pag a sub 3, that's a sub 3, that's 2 to the negative 1, 3 minus 1. So that's why you have 3 minus 1 that's squared there. So times 2 and down the line. So this is actually the explicit formula already. Now for 2 to the n, this is actually a geometric sequence where the ratio of any term to the previous term is 2. You just multiply it by 2. So in general, this is written as a sub n equals kanina na geometric sequence. A sub n c r to the n. So this time, you have your r there, okay, is 2 and your c is 1 sa kanina geometric sequence. But if you are familiar with this is the formula that we have in finding the nth term of your geometric sequence, which is a sub n equals a to the r to the n minus 1. So a here is the first term, r is the second common ratio, and nth term. Okay, so nth term ang hinanap nyo sa a sub n. So ano yung isa? Yung dalawa lang yung dapat nyo tandaan. Arithmetic sequence and your geometric sequence. So you make use, this is the formula actually. So let's have an example. Find explicit formulas for the following. Nth term. How do we do that? Here we have, for letter A, negative 1/2, 2/3, negative 4 over 5, negative 1. This is what we are going to make use of. You have to find the formula. But for letter A, what do you notice first? This is 1, 2, 3, 4, 5. Sa taas. Pero alternating ang sign. negative, positive, negative, negative, positive, negative. So the odd terms in the sequence are negative. Meaning first term a sub 1, and then a sub 3, and then a sub 5. And the even terms are positive. That is a sub 2, a sub 4. Okay, so what do you think would be your, this is 1, 2, 3, 4, 5. What will be your a sub 6 based on this? Natundan nyo, 2, 3, 4, 5, 6 ang sa ubos, oh. This 1, 2, 3, 4, 5. So what is your a sub 2, 4, 5? A sub 6. Anyone? That's a sub 6. Nakita niyo bang pattern? 1, 2, 3, 4, 5. So what's your a sub 6? Walang answer? It is, anong sunod sa 5? It is, are you still with me, guys?
Yes, ma'am.
Oh. Naintindihan pa? Oh, anong a sub 6?
Positive 6 over 7.
6 over 7
7.
positive. Yes.
Yes, ma'am.
Okay? If we have 1, 2, 3, 4, 5. Oh, by the way, may camera dyan sa classroom, ha? If you are not listening, you should not have stayed there kasi camera kayo. Kung nag-stay kayo dyan sa classroom, you are being monitored by our chair. Kabalo mo po ang chair nga mag-online class ko karon kindi. Kabalo man sila na I'm not feeling well sa online class. So 1, 2, 3, 4, 5. And then you have here 6 over, this is 2, 3, 4, 5, 6, 7. Diba? Tapos positive na. Nakuha? Hello, guys. Again, what is this? Ano ang ika-6 term?
6 over 7.
6 over 7 positive. Okay, good. So, notice that the nth term includes a factor of negative 1 to the n. Correct? So, kaning inyong ang nth term, meron tayong negative 1 to the n na factor na kay. Alternately positive and negative man siya. So, you now have a factor of negative 1 to the n. So, naana mo yung idea na before that term, you have this nth term includes that factor. So, next we consider the sequence. Okay, you consider, I emphasized earlier that you have 1, 2, 3, 4, 5. So, in terms of, what is this? This is simply n, correct? Yeah, n, then n plus 1. Okay. How about dito sa baba? Sa denominator. So, both of these sequences are arithmetic sequences. The nth term is the sequence of numerator. Is sa numerator, you have n, pero may factor na negative 1 to the n. All over, sa denominator is n plus 1. Nakuha? So, madali lang siya, di ba? From here, kasi madali yung sequence natin. So, this sequence will give you a sub n equals negative 1 to the n times n, because you have n, 1, 2, 3, 4, 5. Tapos, ang sa baba, okay, here, sa denominator, it's simply just add 1. Diba? N plus 1. So, you now have an idea that the explicit formula for the nth term of this sequence is a sub n equals negative 1 to the n times n all over n plus 1. So that's how you find the explicit formula. You have to analyze all the values there and come up with a reason why you have negative 1 to the n. So you have to write down that the sequence is an alternating from negative to positive. Okay? Okay. Then find an explicit formula for the nth term of this sequence. How about this? Notice na sa taas, it's 3, 9, 27, 81, 243. What is this? 9 is the square of 3. Correct? And then 27 is the square na po of cube of 3. Ang 81 is the fourth. Raised to the fourth of 3. So, makita na ninyo ang sa taas. Unsa man ang sa taas? Kasi formula na inyong ma-derive sa taas. 3 to the yeah, geometric sequence. So, the numerator of the nth term is 3 to the n. Correct? 3 to the n. Okay. When n is equal to 1, 3 lang. When n is equal to 2, 3 squared, 9. When n is equal to 3, paabot dito, 3 cubed, 27. When n is equal to 4, may siyang 81. When n equal to 5, you will have 2. Pero dito lang yun sa numerator. How about sa denominator? Any idea? You have 4, 7, 10, 13, 16. Anong nangyari sa denominator? Is it an arithmetic sequence pa rin or is it a geometric sequence or an arithmetic sequence? Arithmetic sequence, yes.
Geometric, ma'am?
Ang sa ubos, ang numerator. Arithmetic sequence siya. Geometric ang sa taas. Combination man ito. Ito, arithmetic ang sa ubos. You notice? Ang entire is actually the entire thing. Okay? So, combination na yan. Remember, ang hinahanap natin is an explicit formula. Paano isulat ito? Notice na ang sa taas, 3 to the n. Ang sa ubos, lahi po, di ba? 4. O sige, add para makuha ang 7. What was added? 3. Yes. Plus ang 10. What did you add? 13. So na ay certain addends here. So ang sa ubos is actually a arithmetic sequence. An arithmetic. 4, 7, 10, 30. So when you write down the formula now, okay, the denominator of the nth term is the denominator, that will become 4 plus 3 times n minus 1, which is actually your 3n plus 1. So that's how you find it. So explicit formula now will now be 3 to the n all over this one is actually your 3n plus 1. So how did we get this? Again, you make use katong previous na you discussed kanina on how to find the value for formula for your arithmetic sequence. So dapat ma-recognize magud na siya pagkakita ninyo para mahanap ang explicit formula for the nth term of the sequence. So we can actually also find an explicit formula for the sequence. If you are given a sub 1 as 2, tapos given po ang a sub n minus 8n minus 1 for n greater than or equal to 2. And then also if you're given a sub 1 equals 1 half, a sub n is equal to a sub n minus 1 plus 1 half to the n for n greater than or equal to 2. Find an explicit formula for the sequence. So let's just check yung letter A lang para ma-review, no? So, a sub 1 given 2. Ang a sub 2 given as negative 3 a sub 1. Kasi ito yung a sub n term. So, pag a sub 2 na, ang a sub n minus 1 is ang 2. Diba? Which is a sub 1. Then, a sub 3 will now be minus 3 a sub 2. Then, ang a sub 2 kay kanina siya. A sub 2 is negative 3 times 2. Okay, so na may negative 3 daan, tapos naapagid negative 3 times 2, it becomes negative 3 squared times 2. So, I guess you can easily get a sub 1, a sub 2, a sub 3, a sub 4 based on this. So, in general, a sub n now is a sub n equals twice of negative 3 to the n minus 1. I will leave to you yung B, ha? I'll post this now naman para hindi masyado anong oras na ba? Trying to finish it in 11:20. Pero kung may time, pwede natin balikan. Okay? So, a fundamental question that arises regarding infinite sequences is the behavior of the terms as n gets larger. And What do you mean by this? Because your sequence is actually a function defined on the positive integers, we can discuss actually the limits of the terms as n approaches infinity. So you remember yung MAT 51, di ba? Meron tayong limit of a function. This time we talk about the limit of a sequence. So if you consider the following sequences and their behavior as n approaches infinity, then if you have 1 plus 3n, this is a sequence. Diba? What's the first term? 1 plus 3 times 1, which is 4. The second term is 1 plus 3 times 2, which is 7. So you have this, the terms would now be 4, 7, 10, 13. Okay? You would know the next term, correct? Now the terms 1 plus 3n become arbitrarily large as n approaches infinity. Is this clear? Sabot pa sa ani. If n is very, very large, syempre ito, 3 times a very, very large number, this will tend to infinity. No? So it will to become a very, very large number when you take n as a very large number. So 1 plus 3n tends to infinity as n approaches infinity. Nakuha? Is that clear? Ang ibig sabihin nito? Yung ng behavior ng sequence na ito, as n approaches infinity, ang ibig sabihin n approaches infinity, n becomes itong n na to, a very, very large number, then your terms, the terms of the sequence also becomes very, very large. Yan. 1 plus 3n approaches infinity, becomes very, very large as n approaches infinity. As n also becomes larger and larger. Yun ang ibig sabihin. Nakuha?
So, ang answer, ma'am, kaya ang sequence din diverge.
We are not yet talking about the divergence here, and we're talking about yung sa limit pa. Pero you're correct, because when you have when your limit tends to infinity, then the sequence actually is divergent, and you're correct in that. Okay, so we are talking muna about sa value sa limit. So, the terms 1 minus 1 give you what? What number will it give you pag maging masyadong malaki na ang n dito sa taas? Nalimutan niyo na yung ano niya? Limits niya. Di ba mag-zero ito? Pag malaki na masyado ang n, mag-zero ito, di ba? Correct?
Yes, ma'am.
Okay.
It becomes
So
zero.
1, yes. So 1 minus 1 over 2 to the n, these terms tend to what? 1. Kaya mag-zero naman eh. Zero out. So unsay mabilin ang 1 na lang. So when,
Goes to, well, the result, ma'am, goes towards 1.
yes.
When n
Okay.
becomes infinity,
When
one
n
half to the n becomes 0, ma'am.
when n approaches infinity, you say approaches, no? Ang term natin is when n approaches infinity, or mean to say n becomes a very, very large number, this series here becomes 1. Okay? So itong 1 minus, the limit of this is actually 1, because 1 minus this 1 will tend to 0. The result is 1. So it will tend to 1. It will go to 1. How about this one? Negative 1 to the n. When n is equal to 1, we will have negative 1. When n is equal to 2, we will have 1. When n equal to 3, we'll have negative 1. The terms alternate but do not approach one single value as n approaches infinity. Correct? So it does not have any single value. Puli-puli lang siya. Negative 1, 1, negative 1, 1, down the line. So this one, nanatay idea that, di ba ang limit, if we talk about limit, it should be unique. Correct? At this point, wala siyang limit. Kaya mag-alternate ka man siya. How about this? Mag-alternate gihapon. Negative 1 to the n. Negative
Mga
1 half. Negative. Pero, although nag-alternate siya, notice na pag magkadako ang value ani, what will happen? Tapos, mag-large pag will happen. It will tend to
Large. Yung denominator, ma'am.
yes, very good. Pag magkadako ang denominator, what will happen? It will tend to, one lang man ang inyong
Zero, ma'am.
oh, yes, it will tend to
When
zero.
when the denominator reaches infinity, it becomes zero.
Okay. Yes, yes. The terms alternate for this sequence as well. Now, how does it look like? Atong tanawon sa itsura para namoy idea. So this sequence 1 plus 3n equals, diba? 4, 7, 10, 13. And that can be rewritten as when n is equal to 1, your f of n is 4. So 1, 4. Muna siya na. Muna yung mga itsura sa terms of the sequence. 1, 4, 2, 7, 3, 10, 4. Yan. Okay? So as n tends to infinity or approaches infinity, notice na increasing siya. Wala ka pa na dito. Diba? So we're simply talking about the behaviors of this sequence as n approaches.
Until infinity, ma'am.
Patuloy nito, infinity po siya. Diba? So, kaniya sequence will tend also to infinity. Wala siya limit. Huh? That's not the limit here. That's not exist. Okay. So the terms in the sequence become arbitrarily large as n approaches infinity. Yun ang ibig sabihin nun. Makita niyo pa sa dito. So, how about this? This one, sa itsura ni sa drawing. Tanan natin yung sketch. This one, 1 half, 2, 3, 4, 3, 7 over 8, 4, 15 over 16.
Mura siyang arc, ma'am. Balik, nagyapon mo.
Okay.
Tama na siya 1.
Tama na siya sa yes. Tama na siya sa 1. So, na siya limit.
Na siya limit na 1.
Okay, yes, correct. So, makita ninyo, ang CD, naamon sa C, no? Katong ganina. Sa miniature niya, negative 1 to the n, alternate lang siya na. 2, 1, 2, 1, 1 na. Wala siya ipadulungan. Paano lang, baliwalin na. Kasi dali, pag 1,
Mura siya wave, ma'am.
kana lang, balik-balik lang siya diha. So, wala siya padulan. Wala siya limit diha. But, the other one, although pabalik-balik siya mag-alternate siya, naa siya padunglan. The terms in the sequence alternate between positive and negative values but approaches zero. Diba? Mag-approach mo siya zero. Padulong mo siya.
Yeah, limit on 0.
Yes, as n approaches infinity. Correct. Yeah. So, in the two of the sequences, the terms approach a finite number as n approaches infinity. In the other two sequences, the terms actually do not. So, if the terms of the sequence approach finite number L, okay, yun yung kanina, as n, we say that the sequence is convergent. Mula itong ganina nag-storya sa ako, convergent siya, ma'am. Yes. Niya kung dili, otherwise, it is actually divergent. So, ang iyahang limit, katong sequence nga nag-converge is the number L. So, muna ang limit of the sequence. Okay, so muna ang definition. Given a sequence A sub n, if the terms A sub n become arbitrarily close to a finite number L, as n becomes sufficiently large, we say that A sub n is convergent. It's a convergent sequence. And ang limit ana is katunga L. Kung asa siya nag-converge. So you write
limit naman is 1. So convergence na sequence.
yes. Kaning if the sequence is not convergent, katong ganina, nga walay padulungan, then it is what we call your divergent sequence. Okay? Katong n approaches infinity as the terms of the sequence approach n to infinity, tapos n put approaches infinity. Divergent siya. Okay? So, in this case, we have the following. This one, become close to 1 as n becomes very large. Ang ibig sabihin yan, this one is a convergent sequence. Okay? And its limit is 1. Okay? In contrast, from the illustration, we see that the terms in the sequence 1 plus 2n are not approaching a finite number n, no, or L. So we say that divergent, katong ganina, katong 1 plus 2n, divergent siya. So this is what we call your informal definition of the limit. So arbitrarily close lang ang gapin natin at saka yung sufficiently large. Pero, to be more precise, we have actually the following definition. And you are familiar already ano nga definition na ani sa inyuhang MAT071. So, atuan na lang na siyang i-remark here that the convergence or divergence of a sequence a sub n depends only on what happens to the terms a sub n as n approaches infinity. Therefore, if a finite number of terms, kani, b sub 1, b sub 2, are placed before a sub 1 to create a new sequence, b sub 1, b sub 2, b sub n. So, kung convergent na daan ni, then nagbutang mo og a new sequence before it, this new sequence will converge. And mag-diverge siya kung ang bago niyang, kung ang, maski sa paning mga numbers nga ibutang ninyo, mag-diverge siya kung divergent daan siya. Pero kung convergent ting a sub 1, a sub 2, okay, known na convergent din, nabutang mo prior to that sequence, then this sequence, entire sequence will actually converge. Okay, so kung convergent siya daan, kaning a sub 1, then you put another sequence before it, then the entire thing would be convergent. Pero kung divergent siya daan, and you put another sequence before it, then the result will be a divergent sequence. Okay? So it's very important na kabalo mo kung sa mga basic na convergent and basic na divergent sequences. Mga basic values. Okay? Butangan lang man ninyo, pag mabutangan siya sequence prior to it, nakabalo mo nga convergent siya, convergent na siya dayon. Okay? 26 na. Just see. I have 25 more minutes. Further, if the sequence a sub n converges to L, this new sequence will also converge to L. So, kung sa inyahang limit ato, atong a sub n, then it will be the same limit for that term na inyong butangan of b sub 1, b sub 2, and down the line. Siya. So, as n increases, the terms a sub n becomes closer to L. Yan, ito yung limit ninyo. For values n greater than or equal to 1. Notice, no? Padulong ang mga terms niya diha sa limit na L. Yan ang itsura niya. Okay? Goes like that. And the distance between each point n, a sub n, and the line y is equal to L is less than epsilon. If the sequence does not converge, then it is actually divergent. Example, kanina sequence shown in the illustration actually diverge. Kani, kaya nga no, di ba mag-10 man na siya 1 plus 3n, large number siya. Tapos butangan pa ni mga negative 1 to the n, alternately positive. However, different sequences can diverge in different ways. So how is that? Kaning sequence na negative 1 to the n, di ba? Alternately, passive, negative. Yeah. Nidagandagan lang siya sa 1. But when n equal to 1, you will have negative 1. When n equal to 2, you will get positive 1. Okay? So, but so that this one diverges because the terms alternate between 1 and negative 1, but do not approach the value as n approaches infinity. Okay? So, nag-alternate lang siya. Wala siya padungan. Dito lang siya sa duha. Okay? So, it's actually divergent. On the other hand, kaninga sequence diverges. Why? Because the terms 1 plus 3n, it becomes very, very large. Wala siya. It tends toward infinity as n approaches infinity. So, you write it as the limit of 1 plus 3n as n approaches infinity is equal to infinity. So, duha na siya ka reason. So, there is a reason why this one is divergent. And there is also another reason why this one is divergent. And you have to know that. Okay? It's important to recognize that this notation does not imply the limit of the sequence 1 plus 3n exists. Kani ba? Kaning nakabutang ang limit is this one. Yung kag Ani, the limit of 1 plus 3n as n plus equal to. It does not mean na nag-exist ang limit, no? Ang ibig sabihin lang nito is the limit of this number is tending towards a very, very large number. So, the limit still does not exist. Okay? In fact, divergent siya, no? Pero to siya nga divergent, kato nga ano, sequence, limit of 1 plus c to the n as n approaches infinity. Is it clear that it is divergent? Class?
Yes, ma'am.
Okay.
Yes, ma'am.
Right. Okay, good. Writing that the limit is infinity is intended only to provide more information about why the sequence is divergent. So, divergent po siya.
So,
Pwede po niya mag-diverge siya to negative infinity, ha? Not necessarily nga positive infinity. For example, kanina sequence, negative 5n plus 2 diverges to negative infinity. Negative infinity siya as n approaches negative infinity. So, pwedeng isulat is the limit of negative 5n plus 2 as n approaches infinity is equal to negative infinity. As n approaches negative infinity, di ito. Okay, because of this, di ba, isgot na taganina that a sequence is a function whose domain is the set of positive integers. So you can actually use properties of limits of function to determine whether a sequence converges or not. For example, kanina sequence and your function for all integers. So since the domain of the sequence is a subset of the domain of f, if your limit of f of x as x approaches infinity exists, then, kung mag-exist, meaning to say na kay L na makuha, na kay value, then the sequence converges and has the same limit. For example, kanina sequence 1 over n and your related function 1 over x. So, this is 1 over n. We know that the function is defined in all real numbers, but x should be greater than 0. It should satisfy f of x is equal to 1 over x approaches 0 as x tends towards infinity. So, kanina value, as long as x, greater ha, di siya pwede 0. X is greater than 0, kanina x. Okay, ang denominator man ng x. This one will tend to 0 as x approaches infinity. So, this sequence must satisfy 1 over n approaches 0 as n approaches infinity. Pwede siya masulat. The limit of 1 over n as n approaches infinity is equal to 0. Okay? So, if we consider this one, ito ang pagsulat natin. A sequence a sub n, such that masulat yung a sub n ingon ani, f of n, a function in terms of n, for all n greater than or equal to 1. There exists a real number L such that, namoy L, makita ninyo ang value ng L, concept na siya, limit of f of x approach is equal to L. Then a sub n converges. And ang limit ato is your L. Okay? Now, you can use this theorem to evaluate this. What is the limit of r to the n for r greater than or equal to 0 but less than or equal to 1? For example, consider 1 half to the n and also the related exponential function 1 half raised to the x. So the limit now of 1 half to the x as x approaches infinity is equal to 0. So meaning to say, 1 half to the n converges and its limit is 0. So similarly, for any real number r, kaning r to the x, as long as your r is greater than or equal to 0, so 0 na siya, 0 to the x naman, no? Pero less than 1 siya. So decimal number ni siya. Ano? Then, what will you have? Since r to the n converges, on the other hand, if r is equal to 1, then kaning nga limit 1 mana to the x. Mas kung saan pa ninyo ng number na x towards infinity, you have 1 times 1 times 1 times 1. It will always become 1. Correct? So, you have the limit of r to the x as x approaches infinity is equal to 0. As long as your r here is between less than 1 but greater than or equal to 0. But it will be equal to 1 when x approaches infinity. You are going to make use of this later on, in solving for the limit of the sequence. So how it happens if you have here limit of r to the x is equal to infinity? You cannot apply the theorem. However, in this case, just as the function r to the x grows without bound, as n approaches infinity, the terms r to the n in the sequence becomes arbitrarily large. So if you have r to the x greater than 1 na, will happen. Kay greater than 1 mo, makadako na, no? Yung example, 2, r equal to 2. 2 to the, ang imong x kay, say, 1, okay lang, 2 lang. Pero kung 2 to the, say, 1 million, di ka ni siya, 2 to the 1, madako na po siya. So, r to the x grows without bound as n approaches infinity. So we conclude that the sequence this time diverges to infinity if r is greater than 1. So mag-converge lang siya, convergent lang siya if r is less than 1. Pag r equal to 1, the answer is 1. Pero kung r is now greater than 1, then it will be divergent. Summary, katong this, r to the n approaches 0 if 0 is greater than r, less than 1. R to the n approaches 1 if r equal to 1. Pero if r to the n is greater than 1, then it will tend to infinity. So those are the things that you have to recall. Later na nato i-consider r is less than 0. So consider this sequence. Fine. 1146. That one. So the limit of the sequence is determined by the limits of the two sequences. Kani nga limit, unsa man ni kay summation of the limits, no? So you will have convergent ni divergent. Tanawa. Based on what we have learned earlier. 2 over 3 raised to the n.
Convergent, ma'am, if dili
Yes.
mo, if
R
r
is less than
is greater than 1.
Less than 1.
Dili, if r is less than 1.
R is less than. Kani, 1/4 to the n. Convergent, divergent.
Divergent, ma'am, if r is greater than 1.
Unsa man ang R nato? 1/4 man. So, unsa man ang
1/4, right?
So, convergent gihapon. Kay less than 1 man.
1/4.
Mag-10 siya sa 0. So, unsay answer?
Convergent siya, ma'am.
Unsa may limit?
0, ma'am.
0. Yes. Very good. Kanasabtan, no? Converges to 0 plus 0, which is equal to 0. So, these are some algebraic limit laws. I will ask you to read and go through and study these laws later on. It will help you out solve more problems. And then, kaniman siya, ang example, the first example. Let's just discuss the first example para naamoy idea on this topic. Okay, so first example. 5 minus 3 over n squared. Determine whether the sequence converges. If it converges, find its limit. Okay, kani. Ang 5 minus 3 over n squared. Kani, unsa man ni? Divergent ni convergent? Ano na to? Na. So, we know that 1 over n approaches 0 using the fact that we conclude that 1 over n squared. Diba, kani? 1 over n. Limit of 1 over n times 1 over n. Kaning 3 man diri. Constant lang man ang 3, di ba? So, ato lang sang tan-awon ning kaning diri kay kaning 5 constant. So, kaning 1 over n squared lang. Ang 1 over n kabalo na ta na 0 siya. Ang 1 over n mo Kabalata mo 1 over na 1 over a very, very large number, may 0 siya. Yeah, 1 over n squared ba yan? So what do we have now? 5 minus 3 over n squared. Its limit is 5 minus 3, limit of 1 over n squared. Yeah, 0 naman na daan. So 5 minus 3 times 0. Mean to say, ang limit ani is equal to 5. Klaro siya? Na 5 ang limit. But you have to explain it to yung katong mga basic things. Appeal na sa inyong solution. Hindi nyo pwede i-shortcut kung mag-solution mo. Dapat ipakita na kaning limit ani kay 0. That's why you have there 5 minus 3 times 0 because of this 1 over n squared. So that's equal. Nasundan? So ang limit, sa may limit niya, say answer ani.
5, ma'am.
5. Converges, kay kanima ng question. Determine whether or not the sequence converges. If it converges, find its limit. So, converges and its limit is 5. Next number, kani. 3n to the 4th minus 7n squared plus 5 over 6 minus 4n to the 4th. Now, one strategy, I don't know kung natudo na sa inyo sa 61, okay, when you are asked to find the limit, di ba, mag-determine man mag-limit, 51 ba o 61? What you do is you divide it, katong pinakadako na exponent, this 3n to the 4th, so you divide it by tanan. So, katong 3n to the 4th, 4 man ang pinakadako dali, 4. So, 3 minus 7n squared plus 5 over n to the 4th. Kaya nga, no? 3n to the 4th divided by n to the 4th. 3 na lang. Minus 7n squared divided by n to the 4th. So, may mani. Kana 5 n to the 4th. Pati sa ubos, dapat i-divide the same by n to the 4th gihapon. So, 6 over n to the 4th minus 4 over n to the 4th. So, 4 na lang. Is this clear? Kaling first step? Natudlo ba na sa inyo? Na mag-divide siya sa limit.
Yes, ma'am.
Okay. So, ma-recall na ninyo, no? And then, di ba, ang pagkuha is, isa-isahon na pagkuha, ang limit ani, limit of 3, limit of a constant, kay constant man, correct? Then, limit of, as n approaches infinity, then limit of ani, di ba, ma-zero naman ni, kay, madako man ni nga number diha. Then, kung ano po ang limit diha, ma-zero na po ni. Then, kani, kung ano po ang limit diha, ma-zero na po ni, minus 4 mabilin. That's why, from here, you will have this. 3 minus, kaning 7. Limit of, kana siya, plus 1. Plus, over 1 verse n squared. Kanino? Ay, battery running. Padali lang kanino. Ano battery? Lapit na maubos. Lapit na rin ang time natin. Okay. So, here, limit of 3 minus, so what happens? Ang result niya kanina lang, 3 minus 7 times 0 plus 5 times 0 minus 4. So, ang answer is negative 3 over 4. So, kani actually nga method, naana ni sa math either, I'm not sure kung 51 or 61.
So as long as ang limit mo reach ang finite na number, ma'am, mo converge gina siya, ma'am.
Yes. Kung naa siya.
Okay, sige, thank you, ma'am.
Unique dapat ang number pod, ha? Kay basig kung dili unique ang number iyang adtuan, dili pod siya convergent to that. Kay kung duha ka buok, dili pwede. Kay mag-converge ka dapat unique ang imong value para sa limit. Okay? So the sequence converges and its limit is negative 3 over 4. Okay? Sige. Let's go to the other one. Kani. Ano mo idea now daw? 2 to the n squared. Saka na. When n approaches infinity, eh, ba idea? Tanaw lang sa ni. Para na mo idea before niyo yan ang solution. Asa kayo mas mauna mo dagan? Kani? Mas ako? Kana? Let's see. Na. This is your 2 to the x over x squared. So you can use this related function. F of x. Diba? Nagsulta kanina na ang inyong mga sequences is actually related to the function f of x. So, 2 to the x over x squared defined on all real numbers x greater than 0. Since 2 to the x approaches infinity and x approaches infinity as x approaches infinity. So, because of that, you remember your LHR or your L'Hopital's rule. So, ganito siya. Pag naamoy mga values na infinity over infinity, okay, 0 over 0, negative infinity over negative infinity, 1 to the infinity, you can make use of your LHR, or L'Hopital's rule. Which means to say na pag, as long as namoy ana nga value ng gawas, pwede nyo gamitan og derivative. Na? So, kaning limit of 2 to the x over x squared as x approaches infinity, kaning siya will tend to be infinity. Diba? 2 to the very, very large number will be infinity, kaning infinity. So, magawas ka infinity over infinity. So, pwede ninyo magamitan og LHR. And how do you make use of your LHR? You make use of your derivatives. So, dapat memorize po niyo itong mga formula sa derivatives. What is the derivative of a to the u? Diba? The derivative of a to the u is a to the u du. Pero pag you have 2 to the x, what's the derivative of 2 to the x? A to the u ln of a. Kadumdum mo na derivative. That's why you have 2 to the x, that is your a to the u ln of a. Derivative of 2 to the x is a to the u ln of a du. But your du is simply x. So, muna yung derivative. Sa ubos, so the derivative of x squared, 2x. So, kung nakalimot na mo sa mga formula, sa mga derivatives, especially mga basic, exponential, logarithmic derivatives, palihog na lang kong review. Okay? So, notice na kani ang result
Yes,
niya.
ma'am.
Ang result niya is infinity over infinity gihapon. So, because of that, gamitan na pod uli ang LHR. I-apply na pod. So, pag-apply sa LHR, what is the derivative 2 to the ln of 2 squared over 2? But, so man siya, infinity man siya. A very, very large number when x approaches infinity. Divided by 2, then it will be a very, very large number, which is infinity. So, mean to say this one is actually divergent. The sequence diverges. Okay? Ano ba? 1156. So, definition 1.2. Okay, let's just have a recap. A sequence, the limit L. If for every epsilon, there exists a number n greater than 0. That is if n is an integer. Then, kaning nga basic definition sa limits ninyo also applies for the limit of your sequences. So, we have that convergence sa sequence. Parang summarize. So, your theorem says that if your limit f of x as x approaches positive infinity is equal to n, and if f is defined for every positive integer, then also ang limit anang f of n as n approaches infinity is equal to L, where n is any positive integer. So, pwede gamitin ang function, no, f of x as x approaches positive infinity. And if a sequence a sub n has a limit, the said sequence is said to be convergent, and a sub n converges to the limit. Otherwise, pag hindi siya convergent, then it is divergent. So, determine whether the sequence is convergent or divergent. And I still explain this, so we have 3 more minutes. Let me just explain it briefly para mahuman yun. Determine whether the sequence is convergent or divergent. So this is another example. N sine pi over n. So if you consider ang n sine pi over n, inhanglan nato may bawaan for it to be convergent, dapat i-determine nato whether the limit of this exists. Diba? Momento ang concept. If the limit exists, then it is convergent. Correct? Nakuha? Class? Hello? Hi?
The limit does not exist, ma'am.
Okay, ato tanawon kung dili ba siya mag-exist or mag-exist ba siya. Limit of f of x is equal to x sine of pi over x. So, try to investigate your f of x. So your f of x can be written as sine pi of x over 1 over x. Kani inyong n sine pi over n. Pwede man na ma-replace na to with x, no? Sine pi over x over 1 over x. So what is the limit of sine pi over x as x approaches infinity? Kaning sine pi, mas 0 naman ni kay x is very large number. So what is sine of 0? Diba 0? Right? And limit of 1 over x as x approaches infinity is also equal to 0. Okay, ma-divide ba? It's a very large number mas 0. So, because of that, i-rewrite man nato ni, you can apply your L'Hopital's rule, correct? Kaya na naman kay 0 over 0. Apply naman ang L'Hopital's rule if you have that value there. So, limit now of f of x is equal to the limit of, pagkuha na to ang derivative sa sine. Diba? Limit of sine pi over x. So, you take the derivative of this. So, you have negative pi over x squared cosine of pi over x. Ang derivative na pod ani, kaning 1 over x is negative 1 over x squared. And that should give you, kani, okay, when x becomes very, very large, this one, okay, you will now have pi cosine of pi over x. And what is that? That's equal to. So, it looks like, di ba, pag tanaw ninyo, hala, man siya divergent kay n, sine pi over n. Pero pag gamitan siya LHR because you come up with infinity times pi over n man ang concept man sa LHR magamit lang pag you have 0 over 0 or infinity divided by infinity. Diba? So, kinanglan i-rewrite. That's why it was rewritten as such. Sine of pi over x over 1 over x. And, pag gamit niyo na yun sa inyong LHR, nagkuha mo mga derivatives, you come up with a value pi. So, meaning to say, limit of f of n, where n is a positive integer, is actually convergent and it converges to pi. I think you need more time to study on this one. So, I leave that one to you. No? Na kung wala pa nasabdan kaayo, ihatag naman ako ang details. So, you have to study that one. Okay. So, these are the theorems. What you need to, again, I've said earlier, study it back. Ano yung limit of C, ano yung constant. Basic mga limit theorems lang man ni. Okay. Yun ang tunan. So, the references. So, tomorrow, mag-online class lang hapon ta, ha? Pero, I guess, di ba, wala mo'y klase before sa atong klase. So, okay na siguro mo tanan. Ana. Di lang sa ako mag-online class lang sa tagihapon kay isod na matakdan mo. So, let me just have everyone, please open your cameras so that I can stop presenting. Let me just, more options, stop recording. Kaya napod ko yung next class. So, online pod sila. Okay, stop recording. And then, let's have ayaw pa mag-stop mag-record. Let's try to stop recording. So, yan. Okay. Then others, bakit hindi ko makita yung iba? Full screen layout. Hello everyone. Kasi nakaganyan. Ayan. Sige. I hope naka-learn mo kahit pa paano. Lucy, thank you for sharing your cam. Winsky, sige. Sorry, ngunahan nilang gud ta karon ha. Print screen and then let me just nato FB group. Akong anong FB, pag-join na mo sa FB kay para di ko maglisod og contact sa inyo kay naglisod ko contact kani atong FB group. I'll post it here. Sandali ha, ihatag sa na akong FB group para makita ninyo before you go. Ay, nako. Ay. Okay. Ba't ayaw FB ninyo? MAT071. Okay, yan. I'll give the link ha. Mag-join na mo dayon sa FB group na to. Ang lali.
Ma'am, ano sa name sa FB group?
Ha? FB group na to. akong ihatag sa inyo karon kay mag-join na mo dayon kay after 3 days ako na ni siyang i-private karon naka-public pa para maka-join mo. Akong sang kwaon.
Okay, ma'am. Thank you, ma'am.
Oh, ihatag na ko ang link karon diri sa atong chat. Copy. Ayan. Wait kay para naglisod kog contact sa inyo. Here sa chat box. Paki-add to dayon dito and then please join the group kay dito ko ga-announce o ga-post pud sa uban ng mga activities. Okay? Especially pares kanina wala ako naka-contact sa inyo. Anong wala ka mo na-contact sa ano no? Sa inyong can you see it now sa chat box? Na dito ang FB group na to. Kita ninyo? So one more last picture. Did you see the FB group already sa chat box? Okay. Print. Di ko makita yung iba. Sige na lang. Print screen. Okay. And then FB group. Dali. Write something. Paste. Today is October. Say date karon? October 5 ba? Pass? October 5.
Yes, ma'am.
O, sige. So, I will see you online gihapon tomorrow, ha? Okay, lisod na ano mo. O, sige. Bye-bye, everyone. Bye-bye. Thank you for coming. Okay, pakishare na lang sa atong FB group para madali mo makontak, ha?
Bye, ma'am.
Bye-bye. Okay, bye. So, see you tomorrow. Ako lang i-post ang link sa FB group. Ang link na sa FB group. Sige, bye-bye. Ako to sang i-off ang stop recording.